Okay, we're going to learn more about derivatives today. We looked at the power rule yesterday. Given a function like this, we get f prime is equal to 6, or y prime equals 6, or dy over dx is equal to 6. And then we learned the basic rules that if I have a constant, its derivative is 0. And if I have a power function, here's the power rule. And then here are some examples of power rules. Pretty basic rule. And if a function is a polynomial that has multiple terms with it, we just do one term at a time, not too hard. We have some examples that we did. So if you want to do this, f prime of x is negative 10x to the first. G prime of x is 36x squared. Y prime is equal to negative 5 over 6, x to the 0. This is g prime of x is negative 36, x to the negative 4. I should rewrite this as 5x to the negative 2. So I'm going to take its derivative. I get negative 10x to the negative 3. I should write this as negative 5 over 6, x to the negative 1. So I'm going to take its derivative. Y prime is going to equal to positive 5, 6, x to the negative 2. Again, if I have multiple terms, f prime of x, negative 15x squared plus 4x minus 8. And g prime of x is negative 12x to the 5th minus 6x to the 3rd plus 5 over 2x squared minus 1/2. These were many examples that we did yesterday. So we did talk briefly about the graph of sine and cosine and their derivatives, but we're going to go over them today. So the graph of sine starts at 0, 0. Pi over 2 goes up here, 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 and in reverse. And you have this graph that kind of looks like this. This is a sine graph. Let's see if I could draw it more smooth. This is a sine graph. Well, now I want to take its derivative, or the dy dx of it, changing y, we're changing x. So I'm going to shrink this up a little bit. Well, the one thing I know is that at these points here, the mins and maxes always have slopes equal to 0. So I have positive, negative, positive, negative slope, and finish off with a positive slope. And really what happens here is right here in the middle, this slope is equal to 1. It's hard to tell because the way it's drawn, but it is 1. So I'm going to mark my mins and maxes every other dot, and it basically goes positive, 0, negative, and I get something like this. We talked about this last class, that this graph is a cosine graph. So the derivative of sine, so the d dx, or the derivative of sine with respect to x, is cosine of x. Or we call, if y equals sine of x, y prime is cosine of x. Or f prime is cosine of x. And then we have this other thing. When we have what I call coefficients up front, they just go for a free ride. So if you have 5 sine of x, its derivative is 5 cosine of x. If it's a times sine of x, it's a times cosine of x is its derivative. And we learned this last class a little bit. So let's graph the cosine function. So cosine starts at the max, middle, min, middle, max, middle, min, middle, max. We get this function. Actually, the one that we just drew was a cosine function. But again, what do I know? I know that all these mins and maxes, my slope is equal to 0. And right here, the slope is negative, slope is positive, the slope is negative, the slope is positive. So when I draw this graph, so I could put them all on the same page, I get 0, 0, 0, 0, 0, 0. Or my slopes are at the mins and maxes, and I got to go negative to 0 to positive to 0 to negative to 0 to positive, and so on and so forth. And we talked about this last class, that this is a negative sign graph. So what does that mean? That the derivative of cosine is negative sine of x, or y prime is negative sine of x, or f prime is negative sine of x. And again, if I have a coefficient up front, if it's 5 cosine of x, its d dx, or its derivative, is negative 5 sine of x, or negative a times sine of x if the coefficient is a. Okay, we can talk about what we did last class. If we use trigonometry and that cosine is the x, positive x, and sine is the positive y, that means negative sine is here and negative cosine is here. If I draw a nice clockwise circle, sine derivative is cosine, whose derivative is negative sine, whose derivative is negative cosine, whose derivative is sine. This is the f prime circle for trigonometry, sines, and cosines. You should know this very well. Learn it very quickly. So we have another function that we want to graph and figure out its derivative from the graph. Y equals e to the x. This is an exponential growth function. If you remember this, so if I plug in 0, I get 1. I plug in 1, I get e. And this graph has a horizontal asymptote like this. So the graph kind of looks like this, gets very close to the x-axis and kind of grows like this. That is what e to the x looks like as a graph. So let's figure out its slopes. Well, let's see. Over here, its slope is very close to 0. It's getting closer and closer. Right here, the slope is about 1, and this slope is going to infinity. So how do I graph this over here? I need a graph that looks like, let's see, the y value has to be 0, and then right here it has to be 1, and it has to go off to infinity. So let's see. Right there, the slope is 1. On the left side, is getting closer and closer to 0. As I go farther right, it's going to grow to infinity. Well, that graph kind of looks exactly the same as my first graph. And it is. This graph that I just drew is e to the x. So this is the easiest derivative. The derivative of e to the x is e to the x, or y prime is e to the x, or f prime is e to the x. If I have a coefficient up front, coefficients get a free ride. The derivative, or d dx, of 5e dx is 5e to the x, or if you just have a number up front, it's a e to the x. So we learned 3 new derivatives today, of sine, of cosine, and of e to the x. Okay, well, let's do some examples, some of what we learned from the other day and some what we learned today. So f prime of t, and notation is important. I get 6t top minus bottom 1/2 minus 8t, subtract 1, negative 5, and that's a constant, so that's my derivative. I should rewrite this as 4x to the negative third. So when I take its derivative, I get negative 12x to the negative 4. You want to be fancy? Okay. Negative 12 over x to the fourth. Same thing as the other one. I should rewrite this as x to the 2/5. So h prime of x equals 2/5. X times on its bottom is negative 3 and still over 5. I should distribute this. I get 9r to the 10th. So p prime of r is 90 r to the 9th. Now we're going to get to a little bit more difficult ones. I don't like this idea, so I'm going to split it up into two fractions. T to the 5th over t cubed minus 1 over t to the 3rd. And then I realized I could rewrite this as t squared minus t to the negative 3. I haven't taken the derivative yet. I've just rewritten it. Now I can take its derivative. Rewriting it is not taking the derivative. Like this next one. First thing I have to rewrite it. G of x is equal to 2x to the 3/4 plus 6x to the 2/3 minus 9 sine of x. And now I can take its derivative. G prime is equal to, well, 6 over 4 is 3 over 2. X to the 3 minus 4 is negative 1/4. Plus 6 times 2/3 is 4. Top minus bottom, 2 minus 3 is negative 1/3. And then the derivative of sine is cosine, so this is negative 9 cosine of x. That is its derivative. Again, I should rewrite things. S of t equals 9t to the 1/2 minus 4 cosine of x. And s prime is equal of t. It's just 9 over 2. T, 1 minus 2, negative 1/2. And the derivative of sine is negative. The derivative of cosine is negative sine times negative 4 is plus 4 sine of x. Now this one's going to take a little bit more work to rewrite. So I have b to the x is equal to x to the 4th over x to the 1/3 plus 1/2 e to the x. That's the easy part. But I should subtract exponents, and I get b to the x is equal to, well, 4 minus 1/3 is equal to 11 over 3. X to the 11 over 3 plus 1/2 e to the x. So b prime of x is equal to 11 over 3x, top minus bottom, 8/3, plus the derivative of e to the x is e to the x, so this is just 1/2 e to the x because that coefficient gets a free ride. So let's try some matching, and I see that these are the f's, these are the f primes. I see this, I get m equals 0, m equals positive, m is undefined, m equals negative, m equals 0. So 0 to positive, and then negative to 0. Right here it splits where the undefined is at. I would say that's that graph. This one has a positive slope, a 0 slope, a negative slope right here at about negative 3. And I would say that looks like this graph. Positive, 0, negative. And this last graph has m about equal to 0, and it goes up to m goes to infinity. And I would say that's this graph here. Okay, thank you for watching this video.